In this video, I'm going to discuss what is meant by rational numbers, how do you tell if a number is rational or not, and what are numbers that are not rational, the irrational numbers. So the definition of a rational number is fairly simple. It's just any number that you can write in this form. You may not be given this particular form of a fraction, but if you can change the number so that it's equivalent but looks like a fraction where p and q are integers, then it's a rational number. It's important to note that q also can't be zero. Generally in math, when you have something in the bottom of a fraction, you don't want that to be zero, or else it just doesn't make sense mathematically. So what are some typical examples of rational numbers? Well, all of the integers are good examples. So if q equals 1 and p equals 3, say, then you've got the rational number 3 over 1, which is just the same as the number 3. So any integer tends to be, or any integer has to be a rational number. How about if I had 5,298 and I made q minus 318? Yeah, that's a rational number. It's, just because I could write it as a fraction between two integers, doesn't matter if one's positive or negative, any integers work as long as q's not zero. So that's a rational number as well. Okay, how about something like 3.2? Is that a rational number? Well, that 0.2 is the same as 1/5, so 3.2 is the same as 3 and 1/5. And I can convert that into an improper fraction, which is the same as 16 over 5. So there you go. I've taken 3.2, rewritten it as a fraction. Therefore, 3.2 is a rational number. All right, how about a more complicated case? What about a situation where a decimal repeats? Something like 0. Let's say 2, 2, 2, 2, 2, forever like that. You keep getting more and more 2's. The nice way to write that is 0.2 with a bar over the 2. So that means those 2's go on forever. That turns out just to be the same as 2 over 9. I can do that in a different video if you're interested. But this repeating decimal of 0.2 repeating forever is just the same as 2 over 9. Therefore, it is a rational number because I could write it as a fraction between two integers. And it turns out that any repeating decimal can be written as a fraction. So even something more complicated like 0.123, 123, 123, forever and ever like that, which you would just write as 0.123, put a bar over the whole repeating part. I won't work out what the fraction is, but I know that I could write that as a fraction because it's a repeating decimal. Okay, so any repeating decimal can be written as a fraction, so any repeating decimal is a rational number. I guess there's these other decimals too where it just comes to an end. 0.5329, and then no more digits to write. I could write that as a fraction too, right? That's the same as 5329 over 10,000. Therefore, it's a rational number. Okay, so any repeating decimal or any decimal that comes to an end with no more digits to write is rational. So at this point, you might be wondering, well, are all numbers rational? How do you even think of one that doesn't fit this description? It seems like you can write everything as a fraction. Well, it turns out that there are, of course, numbers that you cannot write this way. And irrational numbers are just the ones that you can't write as a fraction between two integers. So all the other numbers, all the other real numbers technically. Um, so one common example of a number that is not rational is the number pi. So we write pi like that. It's a Greek letter because it's just nice to have a symbol for this number because we can't write out all the decimals because it goes on forever. So the thing about pi is, it's approximately 3.14, but if I look in my calculator, there's more digits to write there, and it doesn't stop at the 4. It's just that my calculator only shows so many digits. Uh, you can keep computing pi forever and ever, and the decimal will never end, and also the decimal will never repeat. So you'll never find some pattern of numbers here that repeat, like we had over here with the 1, 2, 3. That does not happen with pi. So pi is a good example of an irrational number because it does not end and it does not repeat. And because it doesn't repeat, I can't write it as a fraction, or it doesn't even end. So, there's no way I can get all the information about what that number pi is. Another example of irrational numbers are square roots or cubic roots. So if you look at something like the square root of 2, my calculator shows, a certain number of digits. But if you keep looking at more and more digits, you'll never get the final answer for the square root of 2 as a decimal. There's always more digits to find, and it never repeats. So this is approximately 1.414, but it goes on forever, and it also does not end and does not repeat. So therefore, that square root of 2 is irrational. So I guess to summarize, in high school, I think you're mostly dealing with real numbers. There's something called imaginary and complex numbers, which go outside of this realm. But in terms of everything you're going to see in usual high school classes, the real numbers, basically everything is rational except for these strange numbers like pi. There's another one called Euler's constant E, which is about 2.71, but it goes on forever and does not repeat. And also any of these square roots or cube roots of integers that are not perfect squares. They are irrational. Like square root of 4 is rational because that's 2. But try to find square root of 3 and that'll be an irrational number. All right, so that's all I have to say about rational numbers. If you have any follow-up questions, you could make a comment and I'll get back to you on it.